we're going to look at function notation with problem solving. So we'll kind of give it a title here. Function notation and problem solving. Okay, there is a heck of a lot to this. 2, 3, 4, 5, 6. 6 parts to this question. So let's see if we can get a good understanding of what the original question is. Pretty straightforward. It's one sentence. So a school's population has been tracked the past decade, so that might be important, and is expressed by this function, p at y, is equal to 2y plus 120, where p is equal to population and y is number of years. Okay, pretty concise in their question. The very first one is find p at 13 and state what this value means. Okay, excellent. So the very first thing we'll do is we'll just take p at y. We'll rewrite it below. 2y plus 120. In function notation, p at 13 is just going to be the idea that we're going to substitute 13 for any value of y in that question. So we had 2, and instead of writing in y, we're going to write 13 in, plus 120. This is simple multiplication and addition. So we get 26 plus 120, 146. Now the question is, what does this mean? This is actually p at 13. So what this means is the population of the school after 13 years. So that's what that 13 stands for. It's the number of years. Remember, that's what y stood for. So we substitute 13. So after 13 years is 146. And 146 is our population. P essentially is equal to that, right? So p at 13, when we've gone 13 years, what is the population? It's 146. Find y when p at y will equal to 300 and explain what this value represents. Same concept, only major difference here is that we have a value for p at y is equal to 300. Okay, so we have the original equation, 2y plus 120. And we're going to substitute in for the p at y, we're going to substitute the value of 300 in. So 300 is equal to 2y plus 120. So the unknown in this part of the question is actually the y value, the number of years. We already know the population. The question is asking when population is 300, so pop equals 300, what is the number of years? What do years equal? That's what we're trying to get at here. So we're going to isolate for y. We'll move 120 to the other side. We'll get 300, subtract 120 over 2y. That'll give us 180. Yep. 180 is equal to 2y. We'll divide both sides by 2 to isolate for y. And we'll be left with y is equal to 90. So after 90 years, after 90 years, the population, I'm going to short form that, will be 300. Okay, let's jump to the third part of this question. What does 120 mean in the function? Okay, what does 120 mean in the function? So we have our function here. 120 most likely, and they haven't told us the number of years, but this probably has to do with the starting of school. So probably the school opened when y was equal to 0. We can kind of make that assumption. And if y equals 0, that means the p at 0 would be 2 times 0 plus 120. In other words, 120. So 120 is the original population when the school opened. And it looks like the school is increasing by about 2 students a year, right? We plug in the value of 1. It looks like population goes up by 2. So the population of that school goes up by 2 every year. So, okay, I'll see if I can fix it. Original pop. Okay. When y is 1,000, find y when p at y equals 1,500. Explain what this value represents. Okay, let me see if I can fix that. This question is identical to this. So what we did below will give us the exact same concept. All we're doing is looking much farther into the future. I mean, probably too far. If a school after 90 years only equals 300, I mean, the population, we'll run through it really quickly, but I imagine that school probably won't be around. P at y is equal to 2y plus 120 for 1,500 minus 120 equals 2y. We subtract 120, we'll have 1,380. We'll divide both sides by 2. After how many years? It looks like 690. After 690 years. That's, I mean, is highly unlikely. I don't know. Maybe there are schools that are 690 years old. I don't know of any. That's all that means. It's the same as before, and same with E. E is the exact same question as our A was. Graph the function. Explain if the school's population is increasing or decreasing based on the shape of the graph of the function. Okay. By looking at this function, if we remember our algebraic rules, we can very quickly figure out what this is. We'll use a graphing calculator to help us out. Remember at year 0, so if this is, actually, this would be P at y, okay? And this is why this question might be tricky, that our independent variable actually happens to be number of years. So when that value is 0, the school's population is 120. And then it just slowly increased constantly. In fact, it goes up by 2 students every single year. So we have a linear graph. We can see that. And what we can do is if we go onto the, under our graphing calculator, we can plug in the original question. We can even write it in function notation here. So P at y is equal to 2y plus 120. And if we'll probably have to zoom out quite a bit here to catch it. Oh, it doesn't like the way. Oh, it's inverted our values. So I guess Desmos doesn't recognize it that way. Let's try this again. With this being x, 2x plus 120. Yeah, so because I wrote y in, this is seeing it as the y-axis. It's not recognizing that this is actually the independent variable here. So this is not a true representation, but the blue one is. The blue one is our linear equation, starting at 120, and then every year it's just going up by a value of 2 students. Now, technically, we can make an argument that this is not a continuous function. Though this linear equation would say that, right? We would go, oops, there it is. We'll zoom in a bit, actually, because I do want to show this idea. Let's see if we can jump in here. It may be a little too complex for what we need to do here. But we can see at the bottom, you know, this is a value of going up 0.5. Here we go, 1 year, right? Actually, what would be nice, I'm going to turn this into a, there we go, we'll turn it into a graph. So at year 0, 1, 2, 3, 4, right? So we've got our values, and we can easily see that every year it's going up by 2 values. But we can make the argument here that what about at a quarter of the year, right? What happens when x is equal to 0.25? What happens to our question? And I can, what's nice about this charting problem, I can put 0.25. After a quarter year, we would have 120.5 students. You can never actually have a 0.5 of a student, be against human rights law. So this is not truly a continuous graph, though we represent it with a linear continuous graph. There are points that don't exist. These probably only exist with whole number values. Though years are continuous, we can count portions of a year. We don't count portions of people. So it wouldn't be until we get an entire full person, maybe every half year, that it would actually show up on that graph. So we do have to keep that in mind. Those question doesn't tell us to look that deeply into it. Let's take a look at all the work we did here.